All right, let's take another example of curve sketching using both the first derivative test and the second derivative test. So let's go ahead and graph the function. Let's look at f of x equal to 1 over the quantity x minus 4. All right, so I want to start with just our basic features of the graph, things like x-intercept, y-intercept, and since it's a rational function, that'll also include any asymptotes. So let's start with our x-intercept. So of course, it's just setting the function equal to 0, or with a fraction, setting the numerator to 0. Of course, 1 never equals 0, though, so no x-intercepts. Y-intercept, just plug in 0 for x. You get a negative 1/4. Okay, vertical asymptote. You can see that our denominator will equal 0 at x equals 4. And then horizontal asymptote, since the degree of the denominator is larger, that'll be at y equals 0. Okay, so there's all our basic information. Now we want to think about our first derivative test. All right, so to take the derivative of this function, since we just have a constant in the numerator, the easiest way to do this is just going to be to rewrite it all to the power of -1 and then just use the chain rule. So our derivative function, if we use our power rule, bring the -1 out front, subtract 1 from our exponent, and then chain rule multiply by the derivative of x minus 4, but that's just a 1. So this would just be -1 over x minus 4 quantity squared. All right, so the first derivative test, we're looking for our critical numbers, or our critical points. So that means set this equal to 0. But again, that never happens, so no critical points. We do, though, have to worry about anywhere that the original function was undefined. So if we look back at our original function, we can see that it's undefined at x equals 4. So although we don't have any critical points, we're still going to make a number line for our first derivative test. And we're going to put on there where f of x is undefined. And we said that was at x equals 4. All right, so that was a vertical asymptote. So let's go ahead and do our number line like usual. Pick our test values on either side of 4. Just go with 3 and 5. And then plug them into our first derivative. And if we do that, we'll get a -1 and a -1. All right, so that means that our first derivative is negative everywhere, which means that it will be decreasing everywhere. All right, so that's our first derivative test. Now let's do the second derivative test. All right, so looking back up at what we found as our first derivative up here, so that was just -1 times x minus 4 to the -2. All right, we can take our second derivative. So again, chain rule, so start by pulling the -2 out front, which will just make it a +2. And then subtract 1 from the exponent, multiply by the derivative of x minus 4. It's our chain rule step, and that's just a 1. All right, so this would just become 2 divided by x minus 4 quantity cubed. All right, in our second derivative test, we're looking for our inflection points. So again, set this equal to 0, but 0 never equals 2, so no inflection points. We again, though, have to worry about where the original function was undefined. And we said that was at x equals 4. For our number line, although there's no inflection points, we still put 4 on there. Pick your test values. So I'll go with 3 and 5 again. Plug them into our second derivative function. And when I did that, I got a -2 and a +2. All right, so that makes this then negative and positive. So where our second derivative is negative, it's concave down. And where it's positive, it's concave up. And remember, 4 was not an inflection point, that's just a vertical asymptote. Okay, so now that we've gone through and found everything with this function, we can go ahead and graph it. All right, so let's try and put everything together here to graph this function. So going back up to what we found in the beginning, we said there were no x-intercepts, but we had a y-intercept at -1/4. We had a vertical asymptote at x equals 4 and a horizontal asymptote at y equals 4. Let's go ahead and add all of that to our graph here. So y-intercept is at a -1/4. Kind of do my best to estimate that. And we had a vertical asymptote, we said at x equals 4. And our horizontal asymptote was at y equals 0. All right, now we had no critical points, but we saw that our function was decreasing everywhere. Okay, it was decreasing everywhere. And we had no inflection points, but we saw that our function was going to be concave down to the left of 4 and concave up to the right of 4. So if we think about this, we know that the function is decreasing everywhere, and we have to, of course, approach these horizontal and vertical asymptotes. Well, if it's decreasing to the left of this x equals 4, that means it has to fall below the horizontal asymptote, because if it were above, it'd be increasing. And then to the right of 4, again, we know that it's decreasing, which means that it has to fall above the horizontal asymptote, because if it were below the horizontal asymptote, it would be increasing. So just to kind of sketch this in, and I'm just looking for a rough sketch on this, we would end up with something like this. So we can see to the left of 4, it's decreasing, and it's concave down, right? Concave down, just like we saw with our second derivative test. And then to the right of 4, I'm not worrying about specific points here, I'm just looking for a general shape. To the right of 4, we have our function that is again decreasing, but concave up. Okay, so there's a rough sketch of this function using basic algebra, first derivative test, and the second derivative test. All right, so there are several more examples in the notes that I posted on Blackboard, but that's just kind of a quick overview of our second derivative test and curve sketching.